Vous rentrez vos données personnelles, dont nous allons parler bien évidemment. On verra comment les monétiser par la suite. Et vous pourrez rentrer sur les différentes sessions pour réagir et poser des questions. Ça me permettra, à la fin de chaque panel, de les adresser à nos intervenants pour qu'ils puissent y répondre. Voilà. Alors, je vous donnerai quelques consignes logistiques. Ça sera avant la pause de tout à l'heure. Je vous en redonnerai au moment du déjeuner. Je ne vais pas vous alourdir avec ça pour le moment, car notre premier intervenant, je vais lui demander de nous rejoindre, Monsieur Amr AWADALLAH, qui va nous faire sa première intervention. Il a 30 minutes. Je vous demande de l'accueillir. C'est Amr AWADALLAH. Monsieur Amr AWADALLAH, so your intervention will be in English, please. So, translation boxes were available. You can use them. Si vous avez pu prendre vos boîtiers de traduction pour la traduction, vous choisissez le canal numéro 2. Alors, si Amr AWADALLAH est le cofondateur de Cloudera, et alors je suis quand même allé fouiner au niveau de Cloudera, et j'ai bien vu que c'était une société bien implantée sur le big data, et notamment qui utilisait le système Adobe que vous connaissez bien, framework open source et ouvert, c'est bien ça. Voilà. Et vous allez aujourd'hui nous expliquer en 30 minutes, puisque vous êtes le premier à intervenir, de nous donner quelques éléments, notamment sur les opportunités que représente l'utilisation du big data, les différents business models qu'on peut avoir, et également les replacer dans le contexte africain et marocain. Si AWADALLAH.
Assalamu alaikum. So, my name is Amr AWADALLAH. I'm from Egypt originally, though I have been living in the United States for the last 20 years now in California. I just came here yesterday from California. It's a very long trip, as many of you know, 20 hours from door to door. But I came here to talk with you about something which is very important. And that is how a big revolution is happening right now across the world in terms of how we leverage and use data to make better decisions and products and services. And in my talk, I will describe to you first what we mean by that, but then I will give you many, many examples from across the industry of how that is being done from our customer base. So Cloudera, my company, I'm one of the founders of that company. We are 8 years old. We started the company 8 years ago. And to illustrate to you how fast this very important space is growing, even though Cloudera was only started 8 years ago, we are now more than 1,400 employees across the world. The company raised more than $1 billion in funding, and the company is valued at more than $4 billion in terms of value. And that is because of how fast this space is growing across the world. We are but one of the very main participants in this space, but there is many more. If you look at history, there is very few revolutions that truly changed the world in significant ways. And one of them is the Industrial Revolution. During the Industrial Revolution, we learned as a human civilization how to use machines to make stuff, how to use machines, and I don't mean computers here, I mean machines as in actual machines, to make carpets, to make chairs, to make doors, houses, many, many things. And companies and enterprises and even countries that learned how to be the leaders of the Industrial Revolution became the leaders of the world from an economic perspective. I mean, China obviously is one of the best examples of that. And today, a very similar revolution is taking place. A data revolution is taking place, which what I'll highlight to you today. And one of the reasons why I love to come to the Middle East, and first time for me in Morocco, very happy to be here, is because I want to see many of us in the Middle East start to realize the potential of this massive data revolution. and leverage that to our advantage. So with that said, I will take you back about 70 years to a very famous guy called Alan Turing. Alan Turing, in the late 1940s, he came up with a test called the Turing Test. And the Turing Test was, how can we tell if we are talking to a computer or talking to a human being? And if we ever reach a point where we can't tell whether it's a computer or a human being, that's when we have achieved artificial intelligence. And that definition was made almost 70 years ago. Joe McCarthy and Marvin Minsky, they are considered to be the fathers of artificial intelligence. They coined the name itself. Joe McCarthy is very famous for inventing the Lisp programming language, which is one of the very early programming languages for doing AI. And Marvin Minsky, in the 1950s, again, this is almost 60 years ago, invented the very first what's called neural networks. Neural networks are self-learning machines that can learn from us and then become better than us. And these concepts existed almost 70 years ago. And many organizations across the world started investing a lot in making this happen. But then a so-called AI artificial winter happened, where these innovations stopped. And these investments from the United States and Japan, they all stopped for a long time. And the promise of AI was almost going to be dead or gone. But then if you look and fast forward today, we have artificial intelligence around us everywhere. I'm giving you some of the common consumer internet examples here, but I'll give you a lot more later on in my talk. So we have things like Siri and Google recognizing us and assisting us in our day-to-day activities. We have Skype doing real-time translation between different languages. We have Facebook detecting faces better than we can detect faces. And then we have algorithms like AlphaGo that is able to beat the world masters of the Go game. And not just beat them, it's actually teaching them, like the Go masters are learning new techniques of how to play the game from the machine. So the question that we raise is, why is this happening now? Why are we now able to fulfill the promise of machine learning and artificial intelligence? What changed over the last 10 years that allowed these concepts and allowed us to achieve these advances? And the answer is three things. The first one is what many of the speakers talked about earlier today, is the fact that today we are better than ever in collecting data. And not just collecting data from computers and servers, because a lot of our business is digitized, but collecting data from the real world. Today, because of mobile devices and sensor networks and satellites and cameras, we are able to collect data from the real world better than ever before. Some statistics, 90% of all the data that we have today was generated within the last 2 years. That's how fast our data capturing sophistication is growing. That said, only half of that data, 0.5% of that data, is being used effectively today. That's the potential that's in front of us. And we expect that growth to continue to grow at a very high rate in the coming years. So I want to give you an example that drives this home and also helps explain what we mean when we say big data. ATM machines. When you go and take money out of an ATM machine, 10 years ago, 20 years ago, the only information that we captured when you took money out of an ATM machine was person X at time T took out Y dollars from account number Z. Very limited amount of data. And that was the only thing we captured. Today, when you go to take money out of an ATM machine, we still are capturing person X at time T took out Y dollars from account Z, but there is a camera taking a picture of your face. If the ATM machine has a touch screen, the way that you move your hand on the touch screen is being captured, the delay between how you move your fingers. Each one of us move our hands in different ways. If you have the mobile app for the bank on your phone, then we are capturing that you're standing right there in front of the ATM machine. So in addition to this very small amount of data, which is the original transaction, we have this mountain of data that we are collecting from the real world that helps enrich the context of that transaction. And you can see how in this example with the ATM machine, this is very, very useful for fraud prevention. It makes it very hard for somebody to steal money from your bank account. With a proper instrumentation like this, only Mission Impossible people can take money from your bank account by copying your face, and apparently for Mission Impossible people it's very easy to copy your face. Because of our sophistication today of how we prevent fraud from ATM machines, thieves are coming up with new ways. I was in Malaysia about roughly a month ago, I was in Malaysia giving a talk about how big data is helping us prevent fraud from ATM machines. And they were telling me that, yes, we have that and we did that, but our thieves now, what they're doing is they're doing something very new. The thieves now, they steal the entire ATM machine. They come with a bulldozer and they just take out the whole ATM machine. And they had this heist that happened in one night where 4 ATM machines were stolen in one night, $500,000. Unfortunately, big data is not going to help with that problem. That's a different kind of problem. But this example shows you what we mean when we mean big data. That's what we mean. It's our sophistication of capturing all of that information. The number 2 very important trend for why we're able to do advanced machine learning and analytics and intelligence today is the availability of affordable storage, computation, and networking technologies. It was very hard to do AI 20, 30 years ago because it was very expensive to build the systems that are able to do it. Only very few military applications and space applications could truly leverage AI. But today, because of advances in storage and memory and networks and GPU technology and CPU technology, the cost is very affordable compared to 20 years ago. So that's the second reason why machine learning and AI is coming back. And then the third reason why it's coming back is the fact that the algorithms and the software that are needed for us to be able to truly leverage that value became democratized. They became available to us. And open source is one of the reasons why. So open source is one way with how we can develop software and share software with each other as companies and countries and organizations. And within the big data space, that is a very real thing. So I have the slide here which shows you the different projects and innovations around open source for machine learning and big data. And you can see how that has been just exploding over the last 10 years in growth. There is so much technology available to you today to do some of the most sophisticated tasks that would have taken you years to develop that are now already available in the open source. And it's making that intelligence and that capability available to all of us. Many organizations now are shifting a lot of their IT infrastructure to depend on open source because they're seeing how open source is innovating and growing way quicker than proprietary software. So this is really the summary of this first section, which is the answer to the question, why is machine learning, artificial intelligence, advanced analytics, why is it happening now? It's happening now because of the combination of these two things. On one side, on the left side, we are able to capture data in the real world better than ever before. And on the right side, we have the proper hardware and software to be able to truly leverage it. So that's kind of the first part of my presentation. I have 3 parts. This is the first one. And I hope you guys remember the 3 reasons. The 3 reasons are, number 1, data. We can get it today better than ever before. Number 2, technology from a hardware perspective is available. Number 3, the algorithms are now available to do this much better than ever before. And what we have been discovering as we work with this, with our different customers that we have been discovering that using machine learning and AI in many cases is better than us humans at doing many tasks. Specifically, some of these tasks that you can see up there. So anomaly detection, the first one up there, is how can we catch weird stuff? How can we catch weird stuff? So what do I mean by that? When a credit card transaction is going through, how can I catch whether that's a normal transaction or a fraud transaction? When some behavior is changing in my network, how can I discover whether I'm being cyber attacked right now? Somebody's trying to hack me. That's not a normal behavior. And many other examples which I share with you in the third section of my presentation. The second very key thing that this technology can do is what's called predictive analytics. Predictive analytics is how can I predict the future as a function of the past? How can I predict a significant event that's going to happen and prevent it from happening if it's a bad event, or enable it to happen much quicker if it's a good event? Clustering and optimization are some of the other key things that this technology can do, and do at scale better than us as humans. So now I have a question for you. Before I go over this slide, I have a question for you, which is, over the last 5 years, why did we shift almost 90% of our picture-taking behavior to be with the camera on our smartphone versus a big SLR camera like the photographer is holding here in the middle of the room? Why did we shift almost all of our activity to be with this camera? And I frequently get 2 answers when I ask that question. The first answer I get, which is a valid answer, is because it's with us all the time. And that's true. However, we had compact cameras that were better than this camera, and we still could have had it with us all the time, and we did not. The real power of this camera, which is the power that we need to enable within our organizations as well, is the agility and the flexibility of once I take a picture, once I capture my data, I can act on that data right away. Right? There is a lot of photo processing apps that can, there is Photoshop. You have Photoshop now on your phone if you want to. There is Instagram, Facebook, email, calendar. I don't have to take out the flashcard like we used to do in the old days and copy the data to a laptop and a computer before I can do something. In other words, the applications, as you can see on the right side there, the applications move to the data as opposed to the data moving to the applications. If you look at us in most of our organizations today, we have been following a flawed methodology, which is the one on the left side, of every time we want to launch a new initiative, a new application, a new service, we make a copy of our data for that service. And that creates a lot of fragmentation and a lot of duplication and a lot of resistance and friction towards evolving what you can do with your data. If you look at how Facebook, the new generation companies like Facebook and Google and LinkedIn and Twitter and Uber and so on are doing, they're doing what's on the right side. They have one physical copy of their data, and instead the applications come on top of the data, not the other way around. It's a very important concept. It's one of the key things that enables us to fulfill the promise of big data going forward. And I stress the word physical because some people say, I can't have all of my data shared everywhere. The key here is physical. It's one copy. But logically, with encryption and with software security techniques, you can still limit it to only be accessed by the applications that need it. But you don't have to wait month on month to copy data to make it available. The data can be available right away, in the same way how on your smartphone, once you capture the data, it's available right away. With the proper permissions, it's available right away. So it's one of the key concepts. In fact, one of the key words I would like you guys to remember is one of the things we're trying to do here is the smartphone of big data. How to create within your organizations, within your companies, within your governments, create a methodology that allows us to capture data and act on it right away without having to copy it first 100 times. I promise this is the only marketing slide I have in my presentation. My presentation is all about content to teach you new concepts. This is the only marketing slide. This is the product that we sell at Cloudera. The product we sell at Cloudera is a platform that essentially allows you to do this. Allows you to collect data of any type, whether that be structured data. Remember this ATM transaction, person X at time T, taking out Y dollars from account Z. We call that structured data. So you can store structured data, but you can also store unstructured data like images and location data from mobile devices and so on. Have all of that data in one place and then extract value from that data in new ways. For the technical folks among you, we allow you to go beyond SQL. SQL, is a very powerful language for doing data manipulations. We have that, but if you're trying to do anomaly detection or predictive modeling, you want to go beyond SQL. And the power of our platform is combining these two concepts. On the input side, we can work with any type of data, and then on the output side, we can analyze it with SQL, but we can go beyond SQL to do more advanced stuff. This is really what this product is about. So now I'm going to move to the last section of my presentation, which is to go over some of the most common use cases that we see in our industry. We have more than 1,000 customers worldwide using this technology in some amazing ways. And I want to share some of these stories with you. First, a very high-level description of what are the use cases that this technology is being used to. There is 3 main use cases, and there is one foundational one below them, number 4. The first one is what we call Drive Customer Insights, or Customer 360, or in the case of a government organization, Citizen 360. The second one is improving products and services using data. The third one is lowering business risk. And then the fourth one is having a modern architecture that can work with any type of data. And I'll explain each one of these in detail and give examples. So the first one is about creating a 360-degree picture of your customers. So you're able to be more consistent, more contextualized, personalized, and more relevant for them. So before I go to that slide, let me give you an example here. I am a male, as you can see. I am in the age range of 40 to 50 years old. And in the United States, but I'm from Egypt originally, however, I live in the United States. And in the United States, usually, when you are a male in the 40 to 50 years old, that means you like golf. So whenever I'm watching TV, or I'm playing, or I'm reading things online, or looking at news, I see a lot of golf ads. I see a lot of advertisements for golf. But I hate golf. I never play golf. I never watch golf. I don't like it. Yet I keep getting these ads for it all the time. Why is that? The reason why that is happening is we as organizations, because we could not deal with big data, meaning all of our customers, we instead came up with a trick. It's a bad trick, but that was the only trick we had at our disposal. And that trick is what's called segmentation. So we created these segments, male in this age range, in that age range, married with children, married without children, this income level, that income level, living here, living there. And then we did our targeting based on these segments. That was the mistake that we did, but we were forced to make that mistake because we had no choice. A very big part of this movement now into the future is because we can and we do collect more data about our customers to move towards what's called micro-segmentation. Move away from I target people based on their age and gender and where they live and how much money they make. Instead, I target them on a much richer profile, as you can see on the right side. In some cases, that profile could have as much as 1,000 different attributes, 1,000 different dimensions describing that person. What they like to read, what they like to click on, what they like to buy, what they don't like to buy, what they don't like to read, what they return to the store after they have bought, etc., etc., etc. Collect a lot more richer information. Now, the targeting is much more effective. It's much more useful. And that's not just targeting for doing selling products. It's targeting for many, many things. Insurance is one example I'll get to in a second. So microsegmentation is one of the most important trends that we are enabling going forward. This one comes from Marks and Spencer. They're a very large retailer. And now they built these much richer profiles about their customers, what they like to buy and what they return. And they are now able to do two things, as you can see in the two bottom bullet points there. One of them is they're able to predict with much more accuracy what their customers are going to buy next week and next month, so they can manage their supply chain much more effectively and make it such that when you come into a store, the item you're looking for is on the shelf somewhere. The other thing they're able to make with very high accuracy, they are able to predict whether a given customer is going to return an item with so high accuracy that I sometimes joke with them and tell them, when that customer is buying it in the store and leaving, you should tell them, do you want to just return this right now? Because they know they're going to return it 2 weeks from now. They just know with almost 99.9% confidence. It's amazing how accurate it's becoming. Royal Bank of Scotland collects a lot of data around their customer interaction with the bank through mobile apps, through online, in-branch stores, through communication on the phone with customer support, through communication on forums, also with customer support, and they're now able to predict with very high accuracy whether a customer is upset. They did not get the answer they're looking for, and they're able to proactively reach out to them and provide them with that answer. And they were able to reduce customer complaints by 25% by doing that. So this is a predictive analytics example combined with segment of one, building a profile for that customer. SFR, one of the largest telecom providers in France, same thing. One of the big problems that all telecommunication companies suffer from is what's called churn. Churn is when a given user leaves you and go to a different competitor. And one of the things that all telecommunication companies want to do is predict churn, predict when somebody is going to leave them as early as possible. If you're only looking at the call data records, how much activity they're making on calls, that's a lagging indicator. By the time the calls go down, that customer has already left you. They're already checked out. They probably already have another SIM card, and they're moving on. You want to catch them way earlier. So by collecting a customer 360 profile that looks at their apps, which apps they're using, how much data they're consuming, much more richer profile, they're able now to predict with much higher accuracy if they are going to lose a customer and extend to them an offer that will help engage them better and retain them more before they leave them. So these are some of the customer 360 profiles. That's the first use case. The second use case, which is the most important one in my opinion, so if you were sleeping, now time to wake up. The second use case is how to build better products and better services using the data at our disposal. And this can lead to all of these different improvements, increased market share, decreased churn, better products, and expand the margins and profits. But I'll better communicate that through examples. This is a very busy slide. I don't expect you to read the slide. You guys will be getting a copy of the slide. But it shows you many of the common manifestations of improving products and services with data within different industries. This is one of my most favorite ones. Whenever you go in for a surgery, you're going in for an operation in a hospital, a surgery, many times the doctors can cure you. They take out your gallbladder that was a problem or whatever. They take out the disease that was bugging you. But while you're going through surgery, you get a bloodstream infection. It's called sepsis. You can see the word there in the title, Saving Lives by Detecting Sepsis. Sepsis, blood infection, if the doctors discover it within the first 2 days after surgery, very easy to fix. They give you a couple of antibiotics and you're going to be fine, you're going to live. If you go home while you have it, and you start having a fever, you start having a headache, and you don't call them. You think, okay, I just had a surgery. Of course I have a fever. The sepsis starts exploding exponentially in your body, and within 5 days, you will die. There's no way to save you. There's no medicine that will work if the infection goes beyond a certain threshold. And this customer of ours, it's a company called Cerner, they collect signals, real-world data from the operation before, during, and after, and they can now predict with extremely high accuracy, this patient is going to suffer from sepsis. Don't let them go home. Or if you do release them home, tell them they have to be double focused on their temperature and their headache and come in right away if they get any early symptoms. And already thousands of lives have been saved using this. Another very nice example is giving voice to premature babies. So premature babies that are born only 6 months old, 7 months old, meaning very early, they still didn't learn how to cry. Not that babies even when they're born at 9 months know how to cry. What I mean by that is sometimes they cry when they're okay, and sometimes they're not okay. They're stressed, but they don't know that they need to cry. And by having proper instrumentation on the baby, some small sensors around their head and their body, we are now able to predict with very high accuracy if the baby is stressed because the light is too much or the temperature is not the right temperature. And a message will show up above their crib saying to the nurse, you need to do this, you need to do that. So we're giving the baby a voice using the signals coming out of their body. That's another example. Internet of Things. Many of you heard about it, extremely important. So some examples from the Internet of Things. This one comes from British Telecom. They're one of our largest customers, and they have a solution now that they are deploying in a number of cities in the UK, where they have these sensors. You can see these circular objects that they put on the road, and these sensors can detect whether a car is parked on top of them or not. And now people have an app. When they're going to the city, they can say, I'm going to arrive there around 10 p.m. A predictive model will tell them, when you arrive, you should roughly look for parking in this area. And when they actually get there, it shows them this is exactly where the empty parking spot is. And that leads to significant savings in terms of the time you need to be looping until you find a place to park. And it also allows cities to be more accurate in collecting income if somebody goes above the time of their meter in their parking spot. This is one of my most favorite examples because this example combines the Internet of Things with customer segment of one. A lot of the insurance companies now in Europe and the US are adding devices in the car that measure how you're driving your car. So before I talk about this, the way we do insurance in the United States today and Europe and many other countries for cars is by segments, right? You look at the segments and what segment you're in, and they give you an insurance price. So for example, my son is 20 years old, and he's a boy. Obviously, my son is a boy. And his insurance premium that we have to pay every month is the highest insurance premium in our house. He has the highest premium because he falls in the segment of boy in the age range of 18 to 25. That said, my son is a very good driver. My son is very careful, very paranoid. He never speeds up. He always follows the signal, brakes in the right way, and so on. I, on the other hand, I have the lowest insurance in my house because I'm a male in the age range 40 to 50. But what the insurance company doesn't know is I was trained on how to drive in Cairo, in Egypt. As many of you know, I assume it's the same. I haven't been to Casablanca yet, so here it looks fine. But in Cairo, I assume it's more like Casablanca, where the stoplight is kind of a hint. Like if it's red, you can go, you can start. It's like you decide what's the right thing to do. So my driving behavior is a very risky driving behavior. Right? I sometimes don't stop and when I should be stopping, or I speed up frequently, actually. Yet I have the lowest insurance because I have been segmented into the segment of 40 to 50 years old male. Then probably you are a good driver compared to your son who's 18 to 25. If I had a device like this in my car, what they do now is based on your driving behavior, you're speeding up, you're slowing down, they know exactly your driving profile, and they now give you a pricing premium based on the probability of you having an accident because of how you drive. Not because of your age, not because of your male or female, not because of like where you live. It's how you drive, and that's how it should be. So now my son, if we had this, we don't have it yet in our cars, but if we had this, my son would be getting the lowest premium, and I would be getting the highest premium, which would force me to drive in a better way, hence saving my life, actually, in the long term. So this solution is starting to grow very quickly right now, because it is the right way to do auto insurance. Predictive maintenance is one of the most important applications of big data and the Internet of Things. Like one of the key headline application for IoT and big data is predictive maintenance. And that is having devices in our trucks, in our cars, in our helicopters, in our planes that collect a lot of diagnostic information. All of that diagnostic information goes to a very large cluster that analyzes that data and does a prediction ahead of time that this truck is going to fail. This specific part in this truck is going to fail 2 weeks from now. And this way we can plan when that truck is delivering something where there's a maintenance center close by, stop by the maintenance center so you can have that work done, hence significantly reducing the cost of fuel and the cost of delays because of maintenance. Same thing, we have that for helicopter. We have a number of helicopter companies as well doing that. Opower is a very interesting company that analyzes the energy consumption in your house. So it looks at how much energy you consume in your home on a per second basis. First, it gives you a nice report so you can see how you consume energy compared to your neighbors. It doesn't tell you which neighbor exactly, but on average. So you can see whether you're over-consuming, under-consuming. But here is the nice thing. By having the overall signal at every second going into your house, up and down and fluctuations, they can now predict whether you have a broken air conditioning inside your house, a broken fridge inside of your house. And you'll get your monthly bill, and you'll get a message saying you need to do maintenance on your fridge. It's like magic, really. It's like, how did you know? Yes, I have a program. I've been lazy fixing it. But they will show you this is how much it's costing you in terms of energy wastage because of you not fixing it. So IoT is definitely one of the key use cases, and improving products using data is one of the key use cases. The third one is about cybersecurity and fraud. So as I said at the beginning of my presentation, and I'm almost done here, a few more minutes, one of the key powers of this technology is discovering weird stuff. Discovering weird stuff. And if you look at cybersecurity, if you look at fraud detection, it's all about that. How can I find weird patterns? How can I find things that should not have been happening? Or what we refer to sometimes as the unknown unknowns. MasterCard is one of our largest customers. They have more than 10 petabytes of data stored in their PCI compliant environment. And they can now detect very sophisticated fraud attacks that they could not detect in the past. So one of the techniques that credit card thieves use frequently to steal money, in the old days, they used to go in and just take like $1,000 from an account. And of course, as soon as you do that, it will get flagged right away. What they do today is they will go to each one of us and only take $2, $3, take a very small amount, and spread that over millions and millions of cards, which makes it very hard for any single bank even to detect it. Only MasterCard themselves, as they aggregate the full data set, can they spot trends like that. And now, because they are keeping all of that data at the lowest granularity possible, they are finding all of these clever, small amount attacks. The attacks that are trying to stay under the radar, essentially. The radar now can catch them. FINRA is the organization in the United States that regulates the stock market. And as you know, one of the key things, the key problems in the stock market is sometimes companies leak what's called insider information, meaning the earnings go out to certain people before others. It should be fair to everybody at the same time. And FINRA collects now all of the activity, 50 billion events per day, 50 billion stock trading events per day. And they analyze that, and again, with very high accuracy, they can find all of these anomalies. All of these cases where there is no way that analyst was able to buy that stock and sell it with this accuracy without having some insider information. And then they go investigate further what's going on. This is another, I can't say who's the customer in this case, but it's a very big bank in the United States that are using us for detecting essentially malware attacks, bad software inside of your network that is reading off information and then sending that information outside of the company. Again, very slowly trying to stay under the radar. How you catch things like that. And then we have, not just in the US, it's famous in the United States, it's well known that one of our main customers is the CIA, is a user of our software. But we have many other governments across the world, and I'm hoping it will happen more in the Middle East, that use our software to analyze all of the data from social media and from other venues and predict with very high accuracy that a bad event is going to take place. Again, predicting the anomalies, something bad is going to happen, and trying to stop that before it happens. And then this is my last use case, and I will conclude. The last use case is really an IT, a technology industry use case, which is our platform. This platform can be used like traditional databases. However, it is 10 to 100 times more effective cost-wise. It's 10 times faster, and it's much more flexible in the amount of data and the types of data it can work with, and then much more agile in terms of how you can consume that data. So very quickly, British Telecom, they were able, if you look at the last bullet point, ignore all the text, just the last bullet point, they were able to increase their data velocity by 15x. They are now doing 5x the amount of data in a third of the time using this technology. Allstate, one of the largest insurance companies, home insurance companies in the United States, to update the insurance premiums for homes, it used to take them, the calculation for doing the risk modeling across all different areas, it used to take them 50 days to update the insurance premiums. Today, they finish doing it in 8 hours. 8 hours. That's the kind of speed you can get with this kind of technology. Dell SecureWorks, you can look at the last bullet point there, how much cost-wise, from $17 per gigabyte of data down now to 0.21 per gigabyte of data. And this is many, many examples of other customers across other industries. Again, we have more than 1,000 customers across the world working with us. So with that said, I conclude. This is my last slide. So if you were asleep again, please wake up again. This is the conclusion, the summary. What is happening here, and the reason why we have this evolution, and essentially really revolution in how we leverage big data, is because we now have a platform that is able to process data of any type, structured data, like that ATM transaction, or images, or videos, or sensor network data. Any volume, you can grow the data as much as you would like, and then do it in a fast, easy, secure way that allows us to build modern applications for Customer 360, segment of one, build a profile accurately for how my son is driving versus me, improve our products and services using data, giving babies voice based on the signals coming out of their bodies, and then lowering business risks, catching fraud attacks or catching bad cyber events that otherwise I would not have been able to catch. And that's it. With that, I thank you very much for your attention.
Thank you, Amr. And I can tell you nobody fell asleep thanks to your very interesting presentation. Thank you, and to give us a lot of materials for our discussions. Ça nous donnera bien sûr du grain à moudre pour toutes nos discussions qui vont suivre. Alors, je vais donc vous laisser prendre une petite pause. Alors par contre, avant que vous vous leviez, s'il vous plaît, on a prévu une demi-heure de pause. Donc vous êtes nombreux, le temps d'aller et en profiter pour découvrir les différents stands. On se donne une demi-heure de pause, mais ça veut dire vraiment, c'est 30 minutes TTC, donc 20 minutes hors taxe. Donc c'est-à-dire, vous prenez 20 minutes, il est moins 10, on va se dire, allez, à 20, on se retrouve ici. Et je vous donnerai une autre consigne tout à l'heure, puisque tout le monde déjà se lève. À tout à l'heure.